There's no mute button, is there?
No.
You don't have a mute button, no.
No.
How unfortunate.
That's right. Clearly, when you whisper, "Is there a mute button?" and the people online say, "No,
No.
there's not a mute button."
Oh, we're timed.
Yep, 3 a.m. Let's go.
Let's go. Are you in control of the slides?
Yeah, I can go. So welcome as we open IETF 126 and the DTN working group. I would just ask if someone near the door in the back could shut the door so we don't get a lot of noise otherwise coming in. Thank you. Okay, well, let's get started. A couple of things in case this is anyone's first IETF, but it's good to go over because it is the first day of the work of IETF. Please understand that by participating in the IETF, you agree to follow all of our processes and policies. If you have not looked at these or if you're not familiar with them, do please take a moment and familiarize yourself with them. I'll leave it here just for a second. A couple of particular things for those both in person and remote. Number one, this session is being recorded and will be made available particularly on YouTube. If you are in person, please make sure that you sign in via the data tracker or using the QR code that's outside for this session. And if you are going to come to the microphone, and of course we are going to encourage that because this is a working group, please both say who you are and make sure that you join the queue so that we as chairs understand that you are here and have questions. Similarly, if you are participating remotely, please make sure that your audio and video are off unless you are presenting, just to help save with some bandwidth. We have not really had issues with this, but we have conduct guidelines. We are going to have a lot of interesting technical discussion. We should be hard on problems and easy on ourselves. So please be respectful as we talk through any of the things we need to talk through. There are a variety of resources. If you have found this room, you know how to look up the resources as to where things are. All right, a few things. We do have a shared notepad that's integrated. My request is that as many people as possible join that. We do have pretty good AI tools that help make summaries, but people are still needed, and we would encourage it.
And one of the critical reasons for joining is as people say their names very rapidly, Adam, who is the group secretary who does a pretty good job of recording the bulk of the notes, can just guess how to spell your name. And if you'd like it spelled correctly in the minutes, that's your chance to get it right.
Absolutely. Okay, we have 2 sessions. Of course, this is the longer one at 2 hours, and then we have another session on Thursday. The agenda for session 1 has been crafted in a particular way. Administrivia is what we're going over right now, and then we have a series of presentations. Historically, and those who have been at the working group, particularly recently, know that we tend to run short on time as we get into the discussions. So we have tried to create a experience over this week between Monday and Thursday where we're not going to be so constrained and we should feel the ability to have the discussion. And so what we want to do is we want to use roughly the first hour of this working group time to go through the presentations, bookmark where possible the significant discussion issues, and then come back in the remaining 50 minutes of open mic to make sure that we can go through and have the discussions that we want otherwise. And we're going to try and keep to the schedule of presentations because we have remote presenters who will be joining at a particular time. So we want to keep the first half of the schedule open. But otherwise, that's where we are. Are there any agenda bashes, anything we want to talk about or make sure is represented otherwise before we get started? All right, so with that, let's start with our very first presentation, which is an update on COAP over BP. And Carlos, would you like to present the slides yourself?
As you wish, whatever is easier for you.
Go ahead.
I was going to say, give Carlos the slides. He knows what he's doing.
Yes, please.
We don't know what we're doing.
Pass slide control.
There we go.
There we go. You should have control.
Yeah. Okay. Okay, good morning, everyone. My name is Carlos Gomez. I'm going to present the update of the draft Untitled Constraint Application Protocol, COAP over Bundle Protocol. My co-author is Ana Calveras, and we are both from UPC. On the status of the draft, today I'm presenting revision 04, which aims to address a review from Marco Tiloca. Many thanks, Marco, for all the comments. And we also aim to address comments from the last meeting. Also, there is one related note here, which is that the actual updates are already in version 03, but then right after submission of 03, we realized there was an issue with the figure with a line that was too long that rendered the div quite useless. So we submitted 04 with a fix for the issue. And another point on the status is that the core working group chairs have explained to us that they plan to declare later in the week in the core working group session that this version I'm presenting today, 04, is stable to implement. Then about the table of contents, you may notice that there have been a few changes. Basically, it's changing the order of a few of the sections, which are the security considerations, IANA considerations, and acknowledgements. And now the order should be correct and according to RFC 7322. Otherwise, the main structure is stable, and only there have been updates in the content of these sections in some part of the security considerations, as I will present later. So some of the updates in 04 are in section 5, which discusses the bundle that encapsulates a COAP message. Previously, we had a parameter called the maximum aggregation delay, which is the maximum amount of time during which a COAP entity can be aggregating single individual messages into a larger aggregate message. And here we have clarified that the value of this parameter is independent of whether those individual messages are of con or non type. You may recall that con messages are COAP messages that elicit an acknowledgement from the destination endpoint, whereas non-confirmable do not elicit acknowledgements. Then in section 13, security considerations, we also have an update. We already explained previously that there is one risk related with the payload length option, which every individual message in an aggregate message needs to carry. The payload length option is class U for OSCORE, which means unprotected, and that means that an attacker might infer features of the communication based on the payload size of the messages. So we already described a few solutions to this problem. One would be not using the payload length option at all, but then there would be no aggregation functionality. Another one would be adding padding by using the new COAP padding option before OSCORE protection is applied. Another one would be using lower layer security, such as BPSec. And what we have added this time is that there's another approach, which is using OSCORE hop by hop. So OSCORE provides object security to protect application layer messages, in this case COAP messages, and it's intended to be applied at the source of the COAP message, and then this protects the message all the way until the final end destination, even if in the middle there are proxies which might be entrusted. But now there is a working group document in the core working group, which has introduced as well the concept of OSCORE capable proxies. And this means that now such proxies are able to apply a layer of OSCORE protection as well. So now it is possible to have OSCORE hop by hop, meaning from the actual source COAP endpoint until the next OSCORE capable proxy, or between OSCORE capable proxies, or from OSCORE capable proxy and the final COAP destination endpoint. So with this functionality, a class U option can be promoted to class E, which means protection with encryption and integrity. So if this scenario is in place, this is another way in which it is possible to protect the payload length information in this option. Then we have applied several minor improvements throughout the document. Some of them are technical, some of them are clarifications aiming to use language a bit more accurately. One example is that in some instances we have replaced response with reply, because response has a specific meaning in the context of COAP. Response is generated by the upper sublayer of COAP. However, reply is more general, and some replies might be produced by the lower sublayer of COAP. And we've also applied several editorial improvements, trying to fix typos, language issues, and so on. We've also added forward references to some sections in the document. And we've also made text references to sections, figures, and actual references as hyperlinks, trying to make the experience of the reader easier. And yeah, as we already stated in the last meeting, we believe that the document may be approaching a state where we may want to request a working group last call. And related with that is the comment that I made at the beginning that the chairs of the co-working group plan to declare later this week that version 04 is stable to implement. And in the meantime, reviews and implementation feedback would be very much welcome. So that was everything from my side. I don't know if there may be any comments or questions.
I have one, which is I think it is all continues to be excellent work, and I'm very glad to hear that we believe that this will be tagged as stable to implement. Do you see a benefit in waiting for an initial implementation before going into working group last call, or do you think that we should entertain that in parallel?
Well, we have already our own implementation from UPC.
Yeah.
So that is already available. And I should double check whether, because it's based on a previous version of the draft, what would be the updates needed to be like conforming to the latest version. But yeah, we do have already our initial implementation, and then it would be great if there could be like other implementations and perhaps try to see if there's interoperability between them.
Sure. And that would be my request, is it once you've made that determination that the implementation is completely conformant to the latest version of the draft, putting that out on the DTN mailing list would be good information, and then we can take it to the mailing list.
Perfect. Yes, we'll do that.
First off, I love this stuff. I have a very specific question about the use of .dtn.arpa as part of the URI scheme support within COAP. I think .ipn.arpa seems to be reaching some kind of consensus as that's the way to go. I'm very wary about introducing .dtn.arpa into this document because, speaking frankly, I'm not sure this working group really knows what a DTN EID is beyond the description in RFC 9171. I'm not sure anyone's actually deploying DTN EIDs in any particular way, and their interaction with DNS names as a whole is a bit of an open question. So I'm a little wary of this document introducing, just as a passing comment, oh, there will be a .dtn.arpa. And I'm not sure anyone's spoken to the DNS gods about whether that's viable. And I know it's not resolvable, but once the name starts to exist, it seems to take a sort of de facto, oh, well, of course it exists and we must do something with it. So it's just a little question about that DNS aspect. I'm not sure. I don't want to slow down this document, so I wonder whether actually removing reference to DTN.arpa is a way to make progress without stalling the whole document.
Okay, so yes, that may well be an approach to follow. I'm not sure if would you consider also contacting people from the DNS area or?
Yes. Yeah.
Okay.
So there's part of an ongoing wider conversation about how much DTN and bundle protocol interacts with DNS, what sort of names and shapes of names and RR types, et cetera, is involved. I'll take this comment to the mailing list because I think it's a technical comment, but I think there are, let me review that section and give you some proper feedback on it is the short answer.
But my follow-on question would simply be if there was an IPN.ARPA instead of a DTN.ARPA, does that?
No, this covers both. In the document at the moment, he happily talks about IPN.ARPA, which is great. No, I don't think anyone's got an issue with that. But it also mentions a .dtn.arpa, and it's that second one.
If it restricts, is there anything technically that's different in this protocol?
No, I understand there would be no difference. Yeah.
Yeah, It's just a naming method.
Yeah.
Okay. Thank you for that. Sorry, any other questions?
No,
All right.
cool.
Thank you so much.
Thank you very much.
Okay. Next up on the agenda are two individual documents from Brian Sipos related to BP Safe and a DTN manifest block. Brian, same question to you. Would you like control of the slides?
Yes, please.
Okay, so granted.
I'll try to stick to the time, hopefully, since there's slack in the schedule.
Yeah,
We won't
exactly.
have problems here. All right, thank you for the time. And I'm going to be talking now about individual drafts that have had some work on them. And I'm requesting just feedback on or advice on or anybody that wants to do trial implementations of these things. The first one is the most recent of the individual drafts, which is this concept of a block manifest block. And the idea here is that there are use cases explained in the document that I'm not going to get into here, but the general concept is it's a way to kind of thumbprint what did parts of a bundle look like at some point of time, so that later on a verifier of the manifest can do something about it. And at least one specific use case has been identified in support of that secure BP audit mechanism, SBAM. And this allows them to not have to invent either a new block type or any kind of security processing, which is helpful on their side. But there are a couple of other use cases that are identified in this draft so far. So if there are any tweaks or comments about the use cases, that's very helpful now. And also if anybody has another use case at all, that's useful to identify now. One of the use cases that is currently in as a kind of a forward-looking mechanism, speculative sort of mechanism, is the notion of being able to mark certain content as it needs to be preserved. And this is in the realm of something like a transit network where somebody else is giving me data. I'm moving it around from one usernet to another usernet. And this marking is supposed to be what has to be preserved. And if it's not in the manifest, I can either ignore it or I can throw it away because the user doesn't care. So it's in the realm of a kind of a quality of service type thing. And it's also, for the perspective of the user, it serves dual purposes, because it's a way to communicate to the transit network, here are things that matter, and you should either enforce what I'm asking or you should throw this away. And the other is, on the far side user, it gives them the ability to verify in a security coverage sense, the things that went in are the same as the things that came out. And the point of the manifest is that it's a two-layer kind of summary, that it's saying, here's what's supposed to be here, here's the hash of that thing that was supposed to be there. And you can verify the manifest in a separate step than you can verify the hashes. So it allows a certain kind of chain of custody of the data. The differences between version 0 and version 1 are really about the encoding structure. There was some feedback sort of tangential to this that was recommending not to hinge any internal processing on things like the CBOR map encoding order, which is a reasonable thing to do. And the uses here didn't really care about whether the structure of the data in particular. So it was split out so that there's a separate purpose code, there's a separate block identity from the metadata map and the block data map. So it's the same information, slightly different data structure, but not a change in the higher level behavior. And then the other thing, we got feedback from the SBAM folks about adding some kind of key identifier to the security block processing. This needs some feedback and needs some work on it, but that addition was made, so at least we have something to talk about. Then, do we want to cover questions now on the individual?
Your choice. Your choice.
Go ahead. Yeah, go ahead. If I'm
Well,
allowed to run over.
no, fair enough. Thank you. And actually, you may have addressed already that was going to be my question is, are you working with the people working on SBAM? And other than the key identifier, are you in agreement on the fields and the behavior of this block?
Yes. Yeah.
Thank you.
So Brian, I may have another use case, and I'll reach out offline about a potential use case, because it's some future work I'm trying to work my way through. My question is, as I was thinking about the manifest block, I think there's some value in putting some indicator in the primary block, and I'm thinking a flag here to say this bundle has a manifest block, so that you can detect the man in the middle who not only strips out blocks, but also strips out the manifest block, so you don't even know there was a manifest block in the first place. It makes sense to me, given the primary block is immutable, that putting a flag in there to say there will be a manifest block makes sense. Is there? I haven't read 01. I apologize. Have you included that? How do you feel about including that?
It's not currently, and for something like this, I think that to me, it makes more sense to enforce something like that through negotiated configuration of policy than like in-band signaling, only because anything that's in-band is still vulnerable to somebody manipulating it. Meaning, if you demand to, it's a more general question than just for this specific block type, but it's a question of if you need something to be there, then that needs to be negotiated out of band in some sense and enforced through policy versus making it discretionary on the data itself.
Yeah, I do take your point. I'm just thinking about how the IETF normally kind of handles these things, where we normally say, look, this is normally configured by some out-of-band process, but there is also an in-band mechanism if you're, say, within a trusted administrative domain, meaning you don't have to have a glorified configuration manager that synchronizes everyone's config to make sure that change got through.
I don't think it would be harmful, but we'd have to talk about what the value is and what happens if there's a discrepancy. What does that imply?
And I think that's good mailing list fodder.
Yeah, mailing list. I'll take it there.
Okay.
And Brian, I'm sorry, just to continue on this. One additional question to help me with my mental model for this block. Is this meant to be a manifest of the blocks that existed in a bundle at the source? Or is this meant to be a listing of the blocks that are expected to be in a bundle at the destination, or something else?
The current definition is it's a selected subset of the blocks at the time that the manifest was added. So it's, think of it as taking a Polaroid snapshot of the bundle, and then later on down the line, comparing the picture that you took to the actual. What that allows for, though, is it allows for saying things like, don't include the previous node in the manifest because it doesn't matter. It's going to be useless.
I definitely agree with that. Would you then presuppose that a bundle could have multiple manifest blocks in it?
Yes, there's no reason why. There's no technical reason why that would be a problem.
Okay. Thank you.
Yeah, and that makes the primary block flag complex, because
yes.
How many? It doesn't indicate how many. It just indicates presence, and should only be added at source, meaning a man in the middle can't add a manifest block. Okay, thank you.
There's a discussion around this.
There's a whole discussion there.
Thank you, Brian. Sorry
All right.
for the distraction.
Yep, that's fine. So that's it for the manifest. There's some things that are worth discussing. The next thing I want to review is the content and the purpose of the security associations with view exchanges safe draft. And I'm not going to dig into a lot of technical details, but I did include some slides that give summary information that I'm going to kind of go through quickly. So within the working group charter, there are topics of OAM and key management. And I believe this does fall under the key management umbrella. And I do want to call out specifically that key management as an umbrella topic covers a lot of different possible things. There's key distribution, there's credential management, there's key derivation and delegation behaviors, key agreement, which is really what's going to be discussed here. And then there's key upkeep, which is kind of a follow-on concept to a lot of these things. And this document is intentionally not covering the topics of key distribution, of credential management, of delegation of authority. Those are topics worth discussing. They're not what is covered here. And they're also things that are covered elsewhere. And right now, this is still an early individual draft. It is, I believe, technically complete. It's something that has had a trial implementation that has enough definition to work out the details and to be able to raise questions about the encodings and the data structures and all that stuff. So I think it's technically strong enough to be discussed at that level. But the use cases need some discussion, and I'm sure there's technical details that are worth talking about. One notable aspect of this is that the initialization, which is the first messaging between peers, makes use of ephemeral Diffie-Hellman over Coze ad hoc, which is an existing RFC out of the Coze working group, or I'm sorry, the Lake working group. And that enables this mechanism to later on, I'll talk about, inherit some future gains that are in the pipeline. And one thing that is, I think, unique to this kind of mechanism, and the reason why this was written up in the whole first place, was that it allows a kind of a unilateral rekeying, meaning the owner of one of these content keys, these symmetric content keys, is able to say at any time they choose, I'm done with this, I've used this on enough data, or it's been enough time, or whatever reason, I want to discontinue this key and start using a subsequent one. They can declare that happening, and everything just works. So there's no negotiation of rekeying like what happens in other protocols like IKE v2, or I think how some of the OSCOR operates. There haven't been recent updates to the document, so I'm just explaining this in summary and soliciting feedback. But the few use cases that are identified here, the ones that are the easiest to understand are the end-to-end security, which is the top picture, where at the source you want to apply data plane security, and at the destination just before delivery you want to accept it. So that's an easy mechanism to understand. The other one that's a little more complex, but still I think easy to understand, is the one-hop transport security. And the idea here is that just before forwarding, you want to source, you want to put some security in the data plane, and just during reception processing, you want to accept it. And so this idea is to supplement or unify security that would be provided by an underlayer. That might mean that the underlayer is not doing anything. It might mean the underlayer is doing things for its purposes, but it doesn't know what an BP EID is, and so it can't do things like authenticate your previous hop. So that's the point of something like this: is let the terminal and the underlayer do its business, but also at the BP node, don't accept traffic that you don't authenticate from the previous node. Then there's two other use cases that are less well defined, but are still at least worth covering, even if they're carved out as saying we don't support these things. And that is a multi-hop security, because that gets into questions of how much you control routing behavior and how much you know about routing paths. And the other one is tunnel security, which is really related to something like bundle in, bundle encapsulation, which I know Rick is going to be talking about later. But the TBDs here are just the fact that we don't have a specific mechanism or detailed configuration to be able to point to say, here's exactly what is meant here. But these two use cases are carved out as saying, by the way, at the current state, these are worth noting because they're different than the first two. They're not the same. I'm going to really quickly go through the fact that this document does call out information bases so that the processing of each of these entities is understood. And the main split is that there are primary security associations, which means how do these two safe endpoints communicate with each other, which is necessary, but not really beneficial to the end nodes. Safe is just a means to get to the secondary security associations, which are what are the data flows at a block level granularity that BPSec is meant to cover. So that's really the whole point of this thing, is to negotiate and establish and upkeep these secondary security associations, which is related to existing BPSec policy and configuration of saying this exact flow between this source, this destination has certain characteristics and it needs certain security. So that's the meat of what this whole draft is meant to expose. And so that's where I think feedback, I'll talk about it in a bit, but feedback is really needed, not just on the safe mechanism, but also on the secondary security association configuration of what parameters are worthwhile to have here. I'll briefly say that there is a sub-layered message structure in here that is meant to separate concerns so that different aspects of the protocol are operating kind of independently, and it's nothing new or shouldn't be anything surprising because there's a lot of similarities with existing protocols and they're called out here. But the idea is that all these safe messages have confidentiality guarantees. They allow pipelining of activities, and the activities themselves are well-defined. They're very short. Some of them necessarily are, I'm gonna skip ahead to the next slide. Some of them are, sorry. Some of them are multi-step about simple negotiations, but some of them are single step just in terms of I'm expressing a thing is happening and the acknowledgement is, yes, I know you're doing a thing. And then on the last slide is just the solicitation for getting feedback on this. And the thing I wanted to say about the ad hoc is that there's ongoing work, and it's going to be discussed later this week at the IETF, about how post-quantum crypto is going to be integrated into ad hoc. And this is a matter of when, not if, and how. So this is something that we'll be able to take gains for free in some sense when that working group works things out.
Brian, good stuff. Quick question with chair hat on. Are you asking for adoption of this document yet, or still noodling on it while Lake?
If there's interest, I'm not opposed to it. It still is at the point where it would be good to figure out how much interest there is.
Yeah. Okay. Second question. I'm assuming this is forward compatible with the COSI context, so the key material is pretty generic. I see
it is, yeah.
Post-quantum, so
yeah, there's subsections in here that explain the need for key material is specific to the context. Each context is going to have different needs.
Yeah.
But there is a call out right now for the two default contexts and the COSI context as a starting point.
Okay, chair hat off. I will be looking at this at some depth and see whether I can roll up an implementation. I think this is really good stuff. Eric, I see you in the queue.
Oh yeah, sorry. Thank you. I did have a quick read of this, and thanks for your clarification, Brian, on the mailing list. For me, I think this feels like a kind of like an Ike V2 for BPSec and something we should have. So I would support adoption.
Oh, great, thank you.
Or adoption call, etc.
Yep. Just to chime in at the end, I completely agree, Brian. This is really good work. My request is if you could make the request on the list for us, and then we will kick off a working group adoption call. To take a moment for anyone who is familiar with this work, and just while we are here together in the room, does anyone have any comment or concern where we should not yet consider this for adoption? All right, thank you so much. Okay. And with that, we will have two presentations by Rick, one for the Echo service, and then separately for considerations on bundle and bundle encapsulation. Rick, do you want me to drive slides?
Yes, unless this flicker works.
Let's see. Let me
We
get
have yet
this.
to try this.
Echo service.
I'm going to see what
Let me pass control to the clicker.
Oh. Cool.
All right.
Did something happen? Yes.
Yes.
Excellent. Something happened. Hello, I'm Rick. This is chair hat off because this is a personal draft. So Echo service. So I have recently updated to version 1 of the BP Echo service. So for those of you who were unfamiliar with the previous Echo service draft, the intention is to standardize how on earth you ping something over bundle protocol. It's a fundamentally important thing to do. This came out of our work on Hardy to make sure that we could actually interoperate at the most primitive level with all the other implementations out there. And in order to do that, step 1 is, can I ping it? And I realized during that work, there is no standardized way to define what service to use for a ping, what are the expected behaviors at a very limited level. Version 0.0 had lots of, it was over-engineered, and I will happily admit it, and I got very good constructive feedback from a number of people to say this is a massively over-engineered solution. It had a whole lot of thou shalt reflect, non-standard behaviors, etc. I've taken that on board, and version 0.1 is much, much more standard. It makes a lot more sense in terms of an IETF document. And bullet 3 here, the headline is, the Echo service is now a box standard request and response wire contract. It's not some magic reflector, etc. And the document is now entirely structured around what a request should look like and what the Echo service as a responder should respond with. It is entirely silent on how one creates these things, what your ping tool looks like. If it's a dedicated tool, is it some background task, is it whatever, it doesn't matter. That's not part of the document. The document talks entirely about the role of the service that responds to your request. So first off, it interoperates. What we've got working now, I have managed to get to work quite happily between Hardy, DTN 7RS, HDTN, DTN-ME, ION, Micro D3TN, the ESA BP implementation, and NASA CFS BP node. So that's a pretty good, the only people I haven't done is Unibo, and I'm really sorry, I just haven't had the bandwidth, and I'm very confident it will work with theirs as well, having looked at it. So yeah, this is either using their in-house Echo service, using their Python API, using whatever, and a little bit of Claude code, thank you, to build out really primitive services that follow this implementation, and it all just works. Having done that, 0.1 is now a write-up of what's involved. Of course, all the hand-rolled and pre-existing services implemented by all these implementations, people just picked a number because there was no standard service number registered or put forwards by the IETF. Most use 7 because it chimes with the ICMP UDP port 7 registration. Others use 2047 because it sounds cool. You'll have to ask the DTN-ME guys why they chose that number. It's fine. Others use random configurable values, none of which are registerable. Why the reflector had to go? Fundamentally, it wasn't standard with 9171. It was actually incompatible. It described a behavior that was not what a normal 9171 BPv7 service should do. It talked about the BPA doing clever stuff and hot swapping out values in the header and shoving it straight back out of CLA. And it just, sure, my implementation could do it because that's the way I wrote it, but it wasn't a good plan. So I'm very happy to go into more depth. Grab me afterwards and we can talk about that. The main terminology of the document now is a request is received, a new bundle is created as a response, and here are the rules on what you set in that bundle. And the short answer, here we go, it's an independently sourced bundle. So the receiving service should create a new response bundle With rules about creation timestamp, it's fresh because you don't get to fiddle with the creation timestamp. That's absolutely defined in 9171. Lifetime, there are some recommendations about what you should do with lifetime, but it's absolutely standard. Basically, go read the draft about the full details about what all these different fields do, but they are the critical fields that you need to understand as a service on how you set that up to reply. Key points. These are not admin records, so don't go turning on admin record flags. Don't go turning on the I require a request ACK, because nobody knows what that is, and you are a response anyway, so don't turn that on. There's some advice in there on what you should do with status reporting. The reason being that the tool that is generating these requests might be trying to do something intelligent with status reports in order to create some kind of useful information to the user. So there's some recommendation in there that you should probably mirror the flags you saw for the status reporting, because it could be useful. And the most critical piece is the payload should be preserved exactly. And this mirrors IP ping, where the source tool puts something it is interested in getting back in the payload with the expectation that it comes back identically, so that it can start doing its stats and checks and whatever. So the responding service should absolutely not touch the payload. And this is the only bit that remains from it's a reflection. So you reflect the payload, but it's a brand new bundle because that's normal BPv7 behavior. We include rules about when not to respond, because it's important to realize when one shouldn't. Null source makes no sense, don't respond. Admin records, no, don't do that. That's also a stupid thing to do, but we have to explicitly say that. And only respond once. Don't start trying to do sort of helpful retries and that kind of thing. It just breaks stuff. These are just useful rules to have into the document so that we get consistent behavior between interoperable implementations. There is no obligation to do anything with extension blocks or security. BPSec works like BPSec does. If you want to put BPSec on your request, that's fine. It should follow the normal BPSec processing that you have configured and the policies you have in place. If you put extension blocks in, I mean, beyond the normal hop count, bundle age blocks and previous node blocks, if you're putting funky extra stuff in there, don't expect to get them back. Unless you've got some out-of-band configuration which causes that to happen. But a standard behavior should be, I don't care about that extension block, I'm going to respond with an absolutely normal bundle. There's a little bit of information about why some of these things have been removed. Go read the document for more information. There's an amplification attack that we're trying to avoid here by managing some of the BPSec information. In draft 00, I got overexcited and wrote a survey of everyone's format for their payload block and tried to produce a nice CBOR encoding of, well, most people like a timestamp and most people like a bit of this and most people like a padding and all those good things that you would have. It was pointed out to me, and I realized it as well, that actually this doesn't need to be defined. The payload block information is actually private to the ping tool that created the request, as long as the response includes it, unaffected. So there is now some non-normative text in the appendix with some suggestions for what a ping tool should do. That's the ping client guidance, i.e. if you want to do round trip time statistics and you want to do status report interpretation, here is some advice based on what pretty much everyone does and sort of industry best practice. It's not normative, it's advice, and there is therefore no standard payload format. Just some, you probably want a timestamp advice. The other thing I did is I simplified the IANA registration request. So the draft 00, I went and asked for a DTN service name. I thought echo demux or .well-known echo demux or something like that would be a really useful thing to have within the DTN EID scheme. But it occurred to me that fundamentally we don't really know what a DTN EID actually is. There's lots of open questions. The existing well-known services registry that came out in the IPN update RFC didn't include any capability for DTN EIDs. It only specified IPN EIDs. And rather than try and cram a whole bunch of, oh, here's some well-known EIDs for DTN and start to touch on DTN EID formats into a document about ping echo responses. I have left all that out and said simply, I would like an IPN service number. I'd like 128, which is the lowest public reservable IPN service number. And that's the only thing in the IANA questions. I have a working document. It's not even a draft. I haven't published it, where I have put all the text I ripped out, and I'm going to noodle on that and possibly roll it into a bit more of a discussion about DTN. I'll talk about that another day. Yeah, can we have a look at it, please? So I think it's now in a fit state. I can't see much else that needs to change except editorial changes, typographic changes. Please have a look at it. And I would like working group adoption on this, even if it is just to reserve a well-known number, because it seems an omission on our behalf not to have a well-known ping number. Doesn't mean you can't use 7 on your own implementations, but it'd be nice to have a standard. Don't worry about the DTN scheme DMUX stuff. Just forget about that until next IETF, when I hopefully will get it done.
We do have a few people in the queue already.
Okay, I'll shut up.
So it just in order, it's me, then Brian, and then Scott, you're at the mic. My only comment on this was, at least in some security considerations part of the document, we should note that adding extension blocks into something like a ping request is going to allow people to probe the capabilities of the network.
Yes.
And you could certainly imagine different integrity signatures with different contexts or age blocks or other things. And so my initial thought was this would have most utility if no extension blocks were allowed. That's possibly too draconian, but I would just ask that you put some sort of a security consideration that if you add extension blocks to this kind of ping request, the fact that you would get a response back tells you something about the processing ability related to those extension blocks for the BPA that is responding to you. And that may be something you don't want to tell the world.
So yes, please everybody look at the document. I think there might be some validity in expanding the initial sections to say, this is how one might use a ping-like tool within a DTN. So it's slightly beyond security considerations. It's also about administrative considerations about whether you should not allow these things to leave your administrative domain, because fundamentally it's doing network probing. I wonder how much read across we can from the work in the other OAM working groups who have looked at the spread of these kind of tools. But yeah, please, I would love further critique, pointing at lines in the draft.
Brian?
Yep. I think this is a good state, and technically it's all good in there. Similar to what was mentioned previously, is I think having an operational considerations section in there is valuable to cover those topics that you were talking about, and also to maybe get some guidance about things like what level of granularity ought a BPA have when doing things like filtering. You know, what is expected? Is it an on-off switch, or is it something more fine-grained? So this is not a technical question. It's a what would you expect how it is meant to be used.
I welcome contribution from the wider community to make sure we get that correct, because otherwise it's just my opinion.
Scott Burley, that's B-U-R-L-E-I-G-H. Just to help out. This is just a comment, and I would have to reread the document. I may have just missed it somewhere, but I would propose it would be a good idea to exclude pings that are from a null source.
It's explicitly excluded.
Okay,
yeah,
good.
because you can't respond to it.
Right, you can't respond to it. It's the nightmare scenario that I was thinking of. The ping comes from a null source, and the report to is an IMC endpoint, and now you've got a DOS attack.
Yeah, that's explicitly called out in the security
Thank
section. Yeah, hit that one. So yeah. But that's why I need better review, just to make sure I got them all.
Yeah, I would say it's not just administrative; it's operational. This is operational use, and so you might want to probe the ability of processing for certain things, right? And so it's certainly worth a possible mention of security considerations, but also in the operational considerations section.
So chair
I mean,
hat on.
because ICMP ping is like a pretty standard operational tool, right? So
Chair hat on, it sounds like this has a rough approval in the room. So I will ask for working group adoption formally on the list.
Separately on the topic of the format, I think that is richer context is better left for separate protocols. IPPM has stamp and like one-way and two-way measurement protocol stuff. There's a whole bunch of things to standardize.
And that's why I kind of put in the appendix, here are some things you might, but it's entirely non-normative. So you can later work in this group or elsewhere can define exciting payload formats that do exciting things.
Well, if you want the payload to be modified, then I think that
You definitely
don't want that for this, right?
Absolutely
But-
should not be modified.
But for other measurement protocols, you want the response to be modified, usually often in some way,
I
right?
think that's a different
And that's
service.
a different protocol.
Yeah.
Yeah.
That's not the echo service, because I've tried to keep this as very, very simple. This is
That's-
the first thing you implement when you're trying to interoperate.
VP IPERF 3.
Yeah. Coming soon to Cinema near you.
Just a quick question again, while we were in the room together, or while we're online together, is there any concern about whether we should adopt something like an echo service document? All right, thank you. Okay, and next,
Is it me again?
yes. Oh, he has to share slides.
Warren, you're asking to share slides.
Yes.
You put your phone down and offered to share slides.
All the slots for the requested media have been taken. How do we stop sharing? Oh, there we go. Okay. How do we stop the share? Yeah. Oh, wait a minute. There we go.
No, we didn't
Got it.
click the button on this end.
I thought putting Rick one right after the other was going to be simple. I guess I was wrong.
Nothing involving me is simple or straightforward.
Speaking of,
Speaking of, okay, so I imagine there will be much discussion around this topic, and so I will stick to the strict 10 minutes. We'll then let everything else proceed, and we will come back to this because we have lots of room at the end. First off, I do not intend to be contentious here, although I know this is a contentious topic. So everybody be graceful and breathe. So earlier this month, I put out a document entitled Bundle in Bundle Encapsulation. And the purpose of this document was to replace the existing Bundle in Bundle encapsulation with custody transfer. And I'm going to talk about it in two parts. Step one is, why did I do this? Because it seems an unusual thing to do. And part two is what's actually in it, is the technical part. But I'm going to cover the why first. So first off, important point. I'm taking my chair hat off. This is an individual proposal. Ed is chairing this. Okay. So whatever happens with this document, Ed is the chair. So the question hanging in the room is, why did I write a document about BIBE when there are a number of people who have actively worked on this for many years? And the simple answer is that we have to say something about the deprecation of fragmentation. So for those of you who are unaware, the ADU fragmentation mechanism described in 9171 does not work with BPSec. It will work under very specific use cases, but in general, it is not functional. So therefore, we have to be able to deprecate that. And in order to be able to deprecate it, we do, in all due diligence, have to be able to point to a solution for the reasons why you might want to take a big bundle and split it into small parts, and to say, and here is a workable solution provided by the IETF to do that. That is the purpose. Second reason is the existing bundle and bundle encapsulation document has expired twice. It's suffering from a slight lack of impetus from within the working group. There's been open questions for a long time about the custody transfer coupling that has caused it to stall a number of times. And also it's a working group document. So although it was worked on originally by Scott Burley and others and continued to be worked on by Scott, bandwidth has meant that he hasn't had sufficient time to work on it, but it's the working group's responsibility to do this because the working group adopted it. It's a little bit of IETF mechanics going there, but when a document is adopted by the working group, it becomes the working group's. Traditionally, the authors who understand it keep going with it because they understand what's going on. But the rules are, it's up to the working group to fix. Also, good news, people are still trying to fix bundle and bundle encapsulation and get a really good workable solution. Unfortunately, although many of the people working on it are attendees of this working group, they're doing the work in other areas which are possibly less visible to the general IETF community. So I think it is very important that the IETF community, particularly as we need to address this ADU fragmentation, has visibility on what is happening. I'm going to go through this in a little bit more detail. So for those of you who are unaware about 9171 ADU fragmentation, it's incompatible with BPSec, and therefore fragmentation and security are fundamentally mutually exclusive, which is not a good situation to be. We don't want to say you can have security or fit your bundle down your limited contact window. Okay, CCSDS is currently absolutely understanding that this is a problem and is going all guns towards trying to fix this. Okay, both us at the IETF and CCSDS understand that therefore we must deprecate ADU fragmentation. Okay, and I've kind of covered the point about an IETF, we can't deprecate part of an IETF standard except through the release of another IETF standards track document which deprecates it. So that's the fundamental mechanism we must fix. The CCSDS can release a book, and for those of you who don't know about CCSDS, their standards are called books. They cannot release a book which deprecates a feature of 9171. They can propose a technology which solves the problem, great, but the formal deprecation requires an IETF document, and this is just process. Currently no live IETF document, therefore no deprecation on the horizon, and we need to fix that. So a bit of history on bundle and bundle encapsulation. People have been working on it for a long time, different groups, different authors, mostly led by Scott. Scott's been leading the charge on this, and bless you for doing that, Scott, because it's been an uphill struggle. The custody transfer acknowledgement mechanism that crept in and then crept out and got pushed in, and people liked it and then they didn't, and we tried to split the two things apart. There's a problem with the coupling. It's caused a lot of, because of the discussion around it, I can quite understand how naturally it dropped down Scott's list of priorities, because a contentious document is hard to continue to work on. But hey, that's where it is. So these are the important things. Whose work is it? I am not claiming ownership personally for any of this work. This is bundle and bundle encapsulation as it exists at the moment is a DTN working group document. It was adopted in 2018. That gives us some idea of how long we have struggled with this. I've covered this before. Working group documents belong to the working group. Expiry, they expire after 6 months, or even for adopted documents, they expire after 6 months unless they continue to uprev. This document has expired twice now. We can rename, rescope, refinish, whatever we want with the consensus of the working group. And that is all that is being proposed here, is a rescoping, renaming, restaffing, and finishing it. Second point, credit. I am not taking any credit for this work. The credit for all this work exists with the original people who put the work in. If you look at the IETF boilerplate stuff, this is at the top of this Taylor draft, it says my name as editor. The key contributors are all the authors of all the previous work because they actually did the work. I am not claiming to do anything apart from typing up a document. And I want to make that absolutely clear. I'm not after I don't want a gold star to say, hey, I was the editor of a document. I don't care. You know me, I actually don't care. And if one of the original authors wants to put their hand up and say, I will take over as editor, I would absolutely welcome that, because it stops this slight chair conflict, maybe. But equally, I'm very happy to continue on that editorial path. So this is not it's not a fame grab, and I'm not trying to claim any of this as mine. CCSDS, the SIS DTN working group, is doing really good work on exactly this problem. And the document I have written up at the moment is an absolute summarization of the technical aspects. A CCSDS document, for those of you who don't know it, is a very large document with lots of required background information that they require for their documents that we in the IETF don't. So the document that I have edited basically strips out a lot of the CCS required cruft and goes down to the absolute bare mechanics required to make bundle encapsulation work. This draft is not in competition with that work, although it is parallel, and it absolutely adopts everything that is happening in CCSDS. Okay, so this is so that the two strands are aligned. We are talking about the same technology, the same things. There will need to be a wider conversation within CCSDS, but that's when I'm wearing my CCSDS hat and not my IETF hat. The purpose of this document is also to capture what the CCSDS is discussing and driving at the moment and making it public so that we who are not, who don't have visibility into the inner workings of CCSDS can stay abreast of what is being proposed and provide our feedback, as is what the DTN working group at the IETF does, and does well. Okay. The good news is the authors of the CCSDS documents are the same authors who worked on BIBE-CT. So it is the same group, it's the same background, it's the same history. And we'll just get it working. We'll get the mechanism in place, and then we'll argue about what is normative, what is the definitive version. But you can understand how the mechanics work at the moment. So my proposal is, and that 45 seconds is perfect, I am proposing an update and a rename and not an adoption call. So the work has already been adopted by the working group. This is a continuation of the work. I'm trying to kickstart it. The Taylor prefix in the name is a staging artifact. I can't go push out. Sorry, I can, I'm a chair, but I felt it was irresponsible for me to push out a DTN working group BIBE document, which updated the existing BIBE-CT document without bringing it to the working group for discussion. The fact it has Taylor on there is because I wrote it and published it, and that's how the RFC submission tool works, fundamentally. The document that I propose as the next revision in the chain of getting BIBE correct in the working group. If the working group approves of this mechanism of here is an update capturing the latest iteration on BIBE fixes, I propose that it is renamed draft IETF DTN BIBE and added as the next update in the sequence, updating BIBE-CT 05. Next version is just BIBE 00, because we're losing the CT piece. And the continuity is all available in the data tracker, as you would with anything else. And final slide, and then I'll pause and do the technical bit at the end, if that's okay. So what I'm asking the room to confirm is two things. Are you happy with the rescope? And the rescope is just encapsulation, no custody transfer, and the rename, i.e. removing the CT from the document because there's no custody transfer. It's his decision to gather consensus. I am recusing myself from this. If you want it as new work, that's fine. We can do that. We can do an adoption call. We can do it the other way, however you see fit. But there needs to be working group consensus, and we have to fix this. Amazingly, the technicalities aren't the problem here. It's actually a process problem and just getting this work kickstarted. I will pause now, and I will part two, the technical part, I'll do in our spare 50 minutes at the end, where I can actually go through some of the technical details if you want to know what Scott is proposing. Go ahead, Scott.
Is there anybody else in the queue?
Me, but please go ahead. That's
Okay. 2 or 3 points. One is I absolutely endorse this approach. I think this is terrific.
Thank
let's,
you.
Let's absolutely go ahead.
I
with
was
it.
really
Right.
nervous about that.
Yeah, this is excellent. 2 is the work that is being done in the CCSDS Orange Book right now is not only removing custody transfer, but also inserting segmentation
Yes.
and reassembly.
Yes.
And do you intend for this document to do that same thing?
The document as it stands at the moment is everything that was in the Orange Book.
Okay.
It's so yes, and I will get into this in sort of part 2, where it's not only encapsulation, it's also encapsulation with segmentation, which is our new word for fragmentation, because when you say fragmentation, everyone thinks you mean the old thing. So we're using the word segmentation
This is
now
better.
to mean fixed fragmentation.
good.
So you can take a big bundle, slice it into chunks, put each chunk in a new bundle and ship it through and reassemble that some decapsulation endpoint. So it's not just pure tunneling, it's tunneling with chunking as well. So yes, completely, it's everything you wrote.
Okay, great. So my last point is, it sounds to me like we're converging on deprecating fragmentation in 9171 as well. Do we need a separate document for that? Or does this document do it?
I would suggest this document does it.
Oh, okay.
Yeah.
That's
Okay.
the other reason for this document.
That simplifies things. Okay, good. Thank
Yeah.
you.
Yeah. So the purpose is this document says this document deprecates ADU fragmentation, and here is the segmentation technique that solves all the things ADU was supposed to do, but doesn't break BPSec.
I will only briefly mention the irony of taking the CCSDS work of bundle and bundle encapsulation and encapsulating it in an RFC. The point that you made earlier, which
But
is
we're not taking custody of it.
the point made earlier, which is this work can happen in the open, so to speak, because things are easier to access and the technical review is through a larger community, I think is quite driving. I think that it would be a very useful thing to take the technical considerations going in CCSDS and making them available here so that we can have that technical conversation.
Yes.
And get it out as an RFC, and then perhaps that is something profilable back to CCSDS.
I agree, but I don't want to have a discussion about CCSDS processes and how as co-chairs go back to the CCSDS, who we have a working relationship with, and discuss how the alignment between the documents exists. I'll take that offline with the CCSDS guys involved and the authors.
So it was excellent to hear from Scott that endorsement. My quick question is there anyone that does not agree with that approach or has a strong disagreement with that approach, either here or online? Okay, that's what I wanted.
Can I ask a chair hat on? Warren, you're our new AD, aren't you? No, where?
Tommy.
Tommy, there you are. Tommy, I didn't see you. I know you're getting up to speed because you're our new AD. Does this seem like a reasonable approach to you?
Well, and we also have Brian in the queue.
Sorry, that was...
Tommy Jensen, new friendly AD. Yes, it does. I really appreciate all the energy you're putting into drawing the appropriate lines. I don't see anything wrong going on here.
Thank you.
Thank you. All right, Brian.
Yeah, I also want to say that this all sounds great. It sounds like a good approach. And also it's good to see the scope defined in a way that is completely without loose ends.
Yeah, and that's thanks to Scott and Alberto, mostly just actually quite a wide team, really trimming it down to what's absolutely needed, which I think makes for a better document always.
All right,
Oh,
so
shut up.
It'd be good to also not necessarily have rationale in this thing and be able to consolidate some of the convergence layer stuff elsewhere. You know, discussing like commonalities and things like that. Don't worry about trying to do it all together in here.
So I'll cover that in part 2, which I'll defer to later in this meeting, where I absolutely tackle that comment, because that slowed some of the work before.
All right. All right, so we will have that technical part second, but now we will invite up Sabrina Pellegrini to talk about reliability considerations for DTN. Oh, certainly. And here is. If you'd like to
Should I wait for it?
No, that's
Okay. Hi, everyone. My name is Sabrina Pellegrini. I'm one of the co-authors for the Reliability DTN draft, along with Ed Brain and Alex White. We're all at APL currently. All right, so I'm going to give I think more of a high-level overview of what we did in our reliability draft, and I think the real meat of what I want to talk about has to do within the architecture of a DTN network. So I might linger there a little bit longer, but to give a high-level summary, a lot of the updates that we pushed in this -2, we updated a lot of the terminology just to be consistent with a lot of the RFCs that are floating around. In our architecture, which we will talk about a bit, we changed what we called originally the adaptation layer to the convergence layer. We also more formally defined the convergence layer protocol stack, which I'll talk about a little bit more. We also created a new section to make it clear that the reliability that we're discussing in the draft right now is reliability specifically at the bundle layer and not at the other layers just yet. We also just refined what our reliability classes are, sharpened up a lot of the variables that we associated with those classes. And then we also took a first stab at security considerations because that was absent in the previous draft. All right, so just some quick minor updates. We removed a lot of the language that was in there originally that described should and shall statements, and that was because that was a lot of normative information for an informational document. So we got rid of that stuff. We also better aligned the document to be more consistent with the RFC. So we were rederiving, I think, some of the definitions originally, but now we're just sort of referencing a lot of the RFC stuff. And then additionally, I think the more notable item that we updated was we introduced the concept of a convergence layer protocol stack. And essentially that is the collection of protocols underneath the convergence layer adapter. And we wanted to do that for the sake of reliability so that when we talk about reliability, we can talk about the responsibilities and properties of the actual stack and not an individual protocol. So we attempted to depict that on the right here, where you can see the convergence layer adapter and then the subsequent protocols in between the BPA and the underlay. But rather than lingering on this picture, I'm going to go to the next slide, which has potentially a better picture. So when we reasoned about reliability, we split the network into different layers. And we came up with the 4 layers: application layer, the bundle layer, the convergence layer, and then the underlay layer. This is the same as what we had in the original draft, only we changed convergence layer from adaptation layer to be more consistent with language that's currently being used. But this architecture that we've proposed is somewhat inconsistent with the architecture that we saw in 9171. So right now, this is the image in 9171, and you can see that this line right there is the bundle node boundary, and then underneath it, the convergence layer protocols are sitting kind of outside that boundary in no man's land. And when we talk about reliability, we wanted to lump the CLs with the CLA into one layer so that, for example, if you're reasoning about a network and you have underlays that are very reliable, you might not care about the bundle node being reliable because all of your underlays are reliable. But if you do have underlays that you're working with that are unreliable, maybe you'd go back to your bundle node and say, well, let's implement a convergence layer that has a stack that's very reliable. Or what we talk about in our draft right now, which is we'd implement reliability at the bundle layer. But we wanted to separate these so that we could talk about it in that way. So I think right now, like the distinguishing factor between the convergence layer and the underlay layer might be that the protocols in the convergence layer go bop to bop or bundle hop to bundle hop, and the protocols at the underlay layer are just hop to hop. But that is essentially, I think, where we might have some contention right here. And so I'm going to pause because I think we have some time, and I wanted to just gain everyone's opinion and feedback on this architecture that we've proposed. So if that's okay, I'll just pause for questions.
I would just ask, could you go to the next slide that yes, so this is sort of where my questions are. The picture on the left, which is from 9171, does put the convergence layer adapter inside of the bundle node, but the convergence layer being adapted outside of the bundle node and separate from the underlay networks. And therefore, it doesn't seem like an even which layer and how do we reason about this? So I guess my question to the working group, and maybe to Scott particularly, is does this picture on the right of talking and reasoning about a convergence layer protocol stack, the top end of which is a CLA for bundles, and the bottom part of that stack is whatever the underlayer is providing you? Is that a sensible definition of the convergence layer? Question to the working group.
Scott Burley. It has always seemed to me the convergence layer protocol stack made a lot of sense. That when you have a convergence layer adapter, the procedures of the convergence layer adapter only address the application programming interface of the top layer of that stack, but what is actually doing the work of moving data from one physical location to another is the whole stack. So I think that convergence layer adapter still belongs inside the node, inside not within the bundle protocol agent, but within the node and invoked by the bundle protocol agent, and that in turn invokes the APIs of the top layer of underlying protocol stacks. I think that's the way to look at it. And Ed, yes, sorry.
Sorry, to that point, and looking at this, I think the picture on the right has a typo. Under BP, instead of CLP1, I think that should be CLA1, which is the convergence layer adapter to protocol 1 underneath of it.
I think that's correct.
And then that cements the CLA inside of the node between the...
Yeah. It's not yet clear to me, because I need to think about it some more, where the value lies in separating out underlay layer from convergence layer. Because it seems to me that those underlay protocols are an indispensable part of the convergence layer protocol stack. But I'm open to hearing more about that.
I'll make one comment, and then I do see that we have a queue. Unless, Sabrina, you wanted to address that, as co-editor, I can render an opinion.
Yeah, go ahead.
So the thing that we ran into in some of our implementations was the underlayer network itself, which we have to deal with because that's the thing getting with the hops to the next bop, would not give us certain reliability guarantees. And so in some cases, if we deal with a reliable underlayer, the convergence layer stack is very thin, because it doesn't have to do much because there's a high level of trust in the underlayer. But if there's low level of trust in the underlayer, then you may choose a thicker convergence layer stack, because that's the thing that you will put your confidence in getting you to the next pop.
Yep.
Okay, I think it's certainly the case that there can be a range of levels of reliability in the bottom of the stack. Naming it separately suggests to me that we're going to reason about it differently, and maybe that's the case. If we're going to address the protocols at the underlay layer differently from the protocols at higher levels of the convergence layer protocol stack, then it makes sense to name them separately. And I don't yet understand how we're going to do that differently.
Okay, fair point. Rick.
Chair hat off. Yeah, the typo for CLP CLA. I'm in agreement with Scott on this, and my suggestion would be actually where it says bundle node and has that nice ASCII art giant parenthesis, I would remove that. I don't think it's helping. All of this discussion in my mind is a logical architecture in which we can talk about bundle processing. None of this is implementation detail. None of this has value beyond an anchor point for a discussion to say there is the bundle processing agent that sits at the top with apps and stuff. There is some kind of adapter layer where individual interfaces, as I like to call them, but they are CLAs, attach some kind of lower layer, link layer, hop by hop layer, which may itself be recursive and multi-layered and eventually end up with a physical layer, or perhaps not even a physical layer, just a, well, no, Pigeon's a physical layer, I suppose, all the way down. And that stack below the CLA to the actual electrons moving in some way can be massive or tiny or recursive and has different properties, etc. Trying to say that is inside the node or outside of the node, I'm not sure is helpful. I think having an architecture diagram is useful because we can talk about architecture in hand-wavy terms. But let's, if the IP world has taught us anything, let's not get caught up on IP over. I can build you a CLA which is bundle over LTP, over EPP, over AOS, over IP, over BP, over LTP, over, and I can recurse constantly. So, which is difficult to draw. I wouldn't try and over-engineer this. And we have spent a lot of time inventing exciting terminology, which hasn't helped sometimes.
Scott Burley again. I think actually I've been talking with Juan about this quite a lot lately, about the recursive nature of the protocol stack. In that sense, I think that what you say about defining what's inside and what's outside of a node is a good point. I think that we have to recognize that there are networks stacked on top of networks. There are nodes within networks that are stacked on top of nodes within other networks. When you say this is within the node, I think it's constructive to be able to say if I'm establishing a node within a network at one layer of the stack, these are the things that have to be in it, and other things are it depends on things that are elsewhere. So I think constraining the concept of a node to certain things is not unhelpful, but I think we absolutely do have to recognize that it is turtles all the way down.
Just to jump in on that with two comments. One is, I like the idea of defining layers based on their responsibilities, possibly their endpoints, and not simply the protocols that may be in the layer.
Mm-hmm.
Our networks are compositionally stacked and not sort of linear OSI,
sure.
stacks.
And I think that things like having this is at layer 5 is like not useful. Right?
No more.
Yeah.
Maybe never, but no more. The second is the proper place to have this discussion, this layering and the definition of layering and so on in 4838 biz.
Yes. I think that's a constructive idea. Sure.
Yeah.
Yeah.
Okay. All right. Thank you. Brian.
Yes, thanks. One thing that might be confusing this comparison is that the picture on the left is showing logical entities and how they relate to each other. And the one on the right is mixing entities with protocol stacks and layers. And those are valuable things to explain in pictures, but they might deserve to be their own separate pictures, meaning have an entity diagram, have a protocol stacking diagram that relates to those entities, but don't try to mix them together into one picture.
That's
because I think that's part of the possible confusion, not to say that the concepts are wrong, but just the pictures representing some of the concepts.
Yeah, I see what you're saying. Thanks, Brian.
Yeah.
Okay. As I said, I think that's like the crux of what I specifically wanted to gain convergence on here. But to finish out, just a few more of the updates that we actually pushed into the draft. So as I said, we created a new section that made sure it was clear to call out that the reliability classes that we're referencing are specific to the bundle layer So in that diagram, ideally, once we figure out this diagram, we can start talking about reliability at each of the layers and think of it that way. So that's what this slide was all about. Then we've also refined what those classes were. So I encourage you all to read it. And then if you have questions, feel free to push it over email. We also refined and sharpened the variables associated with those classes. And then finally, a lot of the draft talks about the faults that could happen within the network. So what we've done is attempted to map the reliability classes that would be required in order to mitigate those different faults. So there's an updated table in there that you guys can take a look at. And I think that is the last slide. So if there are no other questions, we can
One very quick question.
go ahead.
Talking about your classes,
Yeah.
are you intending to specify that these are the 4 ultimate classes of all time and therefore must be, we can all talk about class 2, or is this a division of different types of reliability for the purposes of describing them in this document? i.e., how does this map to QoS, or does it not?
I think that was still like a debate we're having, whether the classes that we come up with are applicable everywhere, and we can say class 0 means this in every context, or if they're specific to each layer that we're breaking out.
Mhm.
So the bundle layer might have class 0 to 3 reliability, but the underlay layer, the convergence layer, might only make sense to have 0 to 2 class reliability. And so I haven't figured out if we have like an absolute scale that we just can all reference, which would be great. It's just difficult to equate that in words.
Yeah, I understand. My concern is that you will bump up against people's local administrative policy quite quickly,
Yeah.
where someone says, yeah, but I don't want to call your class 2 class 2. I want to call it 23 in my scheme. And then we have this whole argument about toss bits again. And
Right.
it's, yeah.
And if it was
GSCP.
able to be quantifiable, that'd be easier. But I feel like right now we're just trying to describe the classes in words.
That's great. And that's admirable to be able to say there are the following general classes of reliability, and then we can all base the discussion around those.
Yeah.
Just a brief follow-up. If you could go back 2 slides to where the classes are. Yes. So there was an idea here that if we talk solely at the bundle layer and not not a convergence layer, otherwise, the thing that the bundle layer gives you is store and forward. Like one of the things that's sort of a biggie for bundle protocol. And then the way we've talked about store and forward with reliability has been custodial behaviors and custody transfer. And there has not always been a crisp definition of custodial behaviors or of how you react to custody transfer. And if you look at the things that are laid here, best effort or store until forward is different than any kind of custodial behaviors. And then you may have actually types of custodial behaviors. So that may not be a complete list, but it was an attempt of at least enumerating how you deal with storage, and there might be more and different.
Great.
All right.
Cool.
Thank you very much.
Thank you.
Next is DTN Access Gateway for IP Edge Networks. And this. Give me just a moment to get this.
Okay.
And
Yeah.
let me give it. There you
Let's restart.
That's fine. Go.
Oh,
go. Thank you.
good morning, everyone. My name is Jianhao Yu from Nanjing University. Today, I will present our work on a DTN access gateway for IPH networks. Let me begin with the background. Future lunar communication systems, such as LunaNet, will provide an interoperable foundation for networking. DTN is important for deep space backbones. However, even when the backbones use DTN, many local IP networks may still exist at the edge of the DTN domain. Those edge systems may not deploy the bundle protocol or understand DTN semantics, but they may still need to communication across the deep space links. We divided this communication environment into an IP domain and a DTN domain. The IP side has short RTT and can inject continual bits at high rates, and the DTN side use discrete bundles, store carry forward, operational and limited contact storage and link capacity. This created a mass mismatch at the boundary, continual high-rate IP traffic on one side and a discrete capacity-limited bundle transfer on the other. The core question is, how can continual IP side traffic be safely admitted into DTN domain as bounded bundle payloads? To address this problem, we introduced the DTN access gateway. It is a boundary function between an IP-edge network and a DTN domain. On the IP side, the gateway acts as a proxy, as an authorized proxy for TCP or quick connections. On the DTN side, it acts as a bundle potential agent to submit or deliver bundles. The key principle is that the gateway uses the existing DTN stacks. It does not change BP semantics, and it does not introduce a new BP potential element. Once the boundary function is introduced, four main challenges need to be addressed. First, continual IP bits must be converted into discrete and bounded bundle payloads. Second, many independent IP flows may share the one constraint DTN path. Third, the IP access appear continuous available, while the DTN forward depends on the contact, storage, and link capacity. Fourth, those DTN constraints are normally hidden from the IP sender, which may lead to uncontrolled over-injection. I will now explain those mechanisms in the main edge-to-edge operation model. In the main operation model, a pair of DTN access gateway connected to IP edge network cross a DTN backbones. This figure shows an Earth-Moon example. One gateway is deployed on the Earth side and the other on the lunar side. Each gateway connected to the local IP networks, while communication between gateway cross the deep space DTN backbones. The Earth side gateway terminates the local IP connection, receives the bit stream, and converts it to bundle payloads. The lunar side gateway receives the bundles, recovers the ordered bits, and delivers them to target server. Therefore, the original end-to-end IP connection is split into two local IP connections with a DTN transfer between them. The IP connection itself does not cross the deep space link. For the perspective of the two IP system, the deep space transfer is hidden by the paired gateway. The first mechanism is the dynamic bundle payload construction. Each admitted IP side connection is represented as a logic flow. Data from each logic flow enters a shared aggregation buffer. The buffer is bounded and shared, so the idle flow does not reserve unused space. When admission is alone, the gateway extracts the data currently available in the buffer and constructs one bundle payload. That payload may constrain data from one or several logic flows. The gateway does not wait for the buffer to be full. As long as the data is available, the admission conduction is satisfied. It constructs and submits a bundle. It thus avoids unnecessary waiting delay. Because one bundle may carry data from several logic flows, the egress gateway must know which bits belong to which flow and how those bits should be ordered. For this purpose, the paired gateway uses payload subfiles. A subfile may contain a flow identifier, an offset, a length field, and the payload bits. This information is carried inside the bundle payload and is interpretable only by the paired gateway. The next mechanism is contact-aware gateway admission. This main purpose is to prevent the gateway from the injection bundles into DTN without control. Bundle construction and DTN side admission are therefore performed as one admission action. The gateway admits a bundle only when four conditions are satisfied. A service DTN connection is available, the local passing interval has expressed, and the shared buffer contains data, and the DTN side interface can accept a new payload. If these conditions are not met, the gateway will keep the data in the bounded aggregation buffer. The last mechanism is the passive back pressure. The gateway admission rate is limited by DTN site service capacity. However, the original IP connection is terminated at the gateway. The IP sender does not can't directly observe the condition of the deep space link. Its injection rate may therefore remain higher than the DTN admission rate. When this happens, the shared aggregation buffer gradually fills. Once the buffer is filled, the gateway process rate from the IP connections. The available TCP or quick flow control credit is then consumed, and the orange sender is forced to slow. In this way, change in DTN service capacity are reflected to IP sender through the existing flow control. After deploying a access gateway, a natural extension question appears. Can an IP site client directly access a DTN native service endpoint rather than only another IP edge networks? For example, an IP application on Lunar rover may need to request a command service inside the DTN domain. This requests the gateway to provide application level service mapping. This is therefore motivate an optional edge to DTN service access extension. In this extension, the gateway maps authorized IP request to a DTN site service transaction according to local config rules. The gateway passes the request, select the target object and the service endpoint, apply DTN admission control, and then constraints and submit bundles. The slide gives two non-narrative examples. The first is transport adaptation. The same application potential is used on the both sides and the transport bounding changes. For example, HTTP over TCP or quick may be adapted to HTTP over BP. The second is the negative service mapping. Here, application semantics may be different. For example, an HTTP GET request may be mapped to a CFDP file deliver operation. This requires additional mapping rules. Finally, I would like to discuss a possible working group work. The ingress and egress gateway must also understand each other's. If the gateway are deployed independently, a common interoperable contract may be needed. We see four main questions. First, how does an ingress gateway select the correct egress gateway? And how is the IP destination or service map to the egress gateway EID? Second, how does independent gateway integrate the same bundle, including logic flow identifier, date boundary, and bit order? Third, how does the two gateway maintain consistent view of the life cycle and outcome of each logic flow? Fourth, how does a gateway identifier is peer and discover the capability that peer supports? Addressing those questions may require a common gateway application potential carried over BP. I would like feedback from the working group on whether it is a useful standardization problem. Thank you.
Yeah.
Thank you very much. First off, good presentation. Second, good work.
Thank you.
I think this is something which is valuable for interoperability and therefore standardization.
Yes.
I think the mechanisms for bridging IP to BP, I can see a deployment where one vendor's device is on one side and a different vendor's device is at the other side,
Yes.
and therefore an interoperable standard is worth doing. Looking at the slide here where you talk about gateway and target resolution. So I am working with my colleagues to look at how we can integrate bundle protocol information into DNS,
Yes,
specifically for this case,
yes,
so that the IP gateway can say, oh, I need to find out the BP addressing so that for the other end, for the IP, and DNS is a good example.
Yes.
So we will probably push some information out in the next couple of months, and we would like your feedback if that's
Yes.
okay. So yes, I personally support. That's chair hat off and also chair hat on. I think this is very good work. Please submit some
Yes.
drafts.
Thank you very much.
Brian?
Yes, thank you. I think this is a good work and it's a great presentation also. And you hint at it a couple of times in the presentation, in your discussion, but if you do have applications that are known to use HTTP, or as the presentation at the beginning of the meeting discussed, CoAP, that you can take advantage of the fact that HTTP and CoAP both natively have the concept in their architectures of a proxy application. And that can be maybe a useful carve out to say, if you are operating HTTP or CoAP, do something a little more tailored. And if you don't have HTTP or CoAP, then you fall back to this kind of IP encapsulation, which is, they're both valuable things. And I think they both are needed. And drawing that dividing line is useful to be able to explain in operations.
Thank you.
I'm just going to echo what Rick had said already. Good ideas and well presented. I would ask to see a draft write-up of this, a personal draft, perhaps something we could discuss at the next IETF.
Yes.
It is good to see the reasoning that goes into how to best create a bundle from this kind of traffic and not
Yes.
to simply flow it through, because there are many things that could go wrong. So I'm very glad to see that. And I think we're going to want to see the technical details going forward. But chair hat off, very excited for the work and well done.
Thank you. Thank you.
Ben.
Ben, can you step to the mic so we can record?
Yeah, thank you. My name is Ben Roberts. Very good presentation. Really enjoyed it. I'm just thinking really, in this, you've got gateway on Earth, gateway on Moon, and DTN backbone. But do you see maybe if this becomes more normal mainstream, do you see a layer of satellites around Earth that might be as part of a relay? Do you see LEO as part of a relay station, and then GEO? I'm very interested in overall interoperability of LEOs, because they're becoming so many and different, and there's becoming more than one type of LEO. So do you see that as being part of the DTN backbone, having layers of satellites in different orbits?
I might answer that one if that's okay. There are a number of people, a number of space agencies, a number of private organizations, a number of governments looking at all sorts of combinations for infrastructure, including LEO, MEO, GEO, lunar relays, lunar orbital satellites. This technology is built on top of that. So once we have that sort of infrastructure in space, how do we actually use it? So I don't want to stop that line of conversation. Very happy to have a corridor conversation, and I'm sure there are people here who have opinions on that, but I'm going to park that slightly. This is a great architecture separate from how do we actually deploy it.
Thank you. Thank you.
I have one more point, which is doubling up on Brian's point. I think this is a really useful piece of technology for when there are not specific application layer proxies, as you had in one of your slides, to say, oh, there could be a dedicated HTTP proxy or SMTP proxy, or specific protocol proxy, for when users say, oh, I have a special IP protocol, and you go, okay, this will just do IP for you now. So I think it is a really useful tool to go with all the other useful tools that we need to build. So thank you.
Thank you. Thank you.
Thank you so much.
Thank you.
Okay, so we now have 17 minutes remaining in our 50 minutes of open mic time, as we've gone through good discussion. Before we invite Rick back for bundle and bundle technical discussions, are there any other walk-on topics or open mic topics? Oh, please. Oh, no, please come up to the mic. No, well, wherever you'd like.
Just there.
It's closer.
All right. Do you mind if I bring up some slides? or is this?
Can we, if you want to present something, can we fit you in on Thursday?
Sure.
But I think we've got a bit more time. So
Okay.
to ping the DTN chairs,
Yeah.
and we'll arrange that if you want to do some slides. If you want to just make a quick point, go for it.
Well, why don't we do both? Why don't you just introduce yourself, what the topic is, and then otherwise, if there's a presentation, we can put it in on Thursday as well.
Sure. Okay. All right. Good morning, everyone online. My name is Season Tan. I'm with Naval Research Lab. I wanted to bring it to the attention of the working group, some work that's being done on key establishment for space communications. There's going to be a follow-up presentation on Thursday about this, but there are several efforts at the IETF currently and within this working group as well, talking about different methods for key establishment. That is to say, there's existing secure channel protocols within this working group that's already been in works. That's the BPSec line of work that's already been done. But a lot of that actually presupposes some sort of key is already in place. And so, as we develop more and more interoperability and try to have more connection with IP environments, such as last presentation gave, and then also with some of the constrained IP environments that Brian alluded to earlier, with the ad hoc and cozy context and security associations like that. You really do want to think about the manner in which keys are going to be agreed upon by parties in both the end-to-end case, hop-by-hop case, and you want to really think through about how delays and asynchronicity is going to affect that. And so, for some use cases, especially in LEO constellations, near Earth communications, the delay might not matter enough where you can get away with using Diffie-Hellman based key agreement protocols, such as TLS or ad hoc. And in other cases where you have much longer delays, that's going to be probably an issue. You don't want to keep on having to try to or you don't want to have to get stuck at the key negotiation portion, that three-way handshake that the Diffie-Hellman protocol is relying on. And you may want to consider some other means of perhaps key agreement in which you can, in one shot, send the or agree upon the key and have encrypted data being sent at the same time. And so there's work currently in the IETF in a new working group to adopt a new protocol called the Messaging Layer Security Protocol. A lot of the same folks who worked on TLS are in that working group and worked on that protocol. MLS brings that asynchronicity to the key establishment process. It has a lot of other security features, which are nice, such as post-compromise security, which means that if your keys are compromised, you can actually recover security rather than having to tear down and reestablish new connections, which may be expensive in light of the DTN environment. So if you're interested in this line of work, there's a lot of it. There's a lot of other interest being generated at this IETF. There's going to be a Birds of the Feather meeting on Tuesday at 16:30 local time. That's the current working group, spelled CURRENT. It's a much longer acronym. I don't remember the name of it, but we're going to meet at 16:30 on Tuesday. I invite anyone who's interested in security for DTN to attend this working group, and I'll give up my open mic. Thanks.
Could you put that date on the DTN mailing list?
Yes, we'll do. Thank you.
And happy to have the discussion on Thursday. Please, if you do have slides, propose them so that we can get them in the system.
Will do. Thank you.
Are these the same as Britta's?
Sorry, say again.
Are these the same slides that Britta presented before?
Yes, Britta, Ben, myself. Yeah. We've hopped around to several working groups, Tip Top here, Quick, and a few others to solicit this idea. And so there's finally kind of enough people to do a BOF out of this. And so I really do encourage anyone from here interested in security and everything to attend that and voice your support for the working group. I think a lot of the agenda applies to the work that's going on here in terms of security. All right, thanks.
Okay.
So we have 11 minutes. Let's get back to bundle and bundle technical.
Okay. Ooh. The mic has dropped. I'm really glad Scott's in the room because Scott can cover some of the discussion on this one. So I'm going to rely on you to answer some of these questions because I am talking about Scott's work. So I'm going to go fast to slide 13 or 14, I think it was. There. So, quick summary. Bundle and bundle encapsulation as it stands today is encapsulation only. There is no custody transfer. There is no hacking. There is no reliability in there, no retransmission. There is literally put a bundle inside another bundle, best effort. Okay. The tunnel, okay, so the reason being is reliability belongs to some other orthogonal reliability mechanism, either some sort of reliable link layer or some sort of custody transfer signaling, be it compressed, be it whatever, that may be developed or handled bespoke or through the IETF. It is unrelated to whether you put a bundle inside another bundle. Also, the tunnel is deliberately transparent to anything layered above it. So you can put bundles inside bundles, inside bundles, inside bundles, inside bundles until your MTU explodes. And there's nothing to stop you doing that. There is a security consideration that says, careful. Also, it's not an administrative record. We don't need to go reach out to IANA here and ask for special numbers or whatever. You are just like you do with IP and IP or GRE. You can select a particular destination for the outermost bundle and send it there. It just goes to an endpoint that receives it and understands to unwrap it. Point number 3, segmentation included. That means if your bundle is too big to fit down the pipe that you must shove it down, I'm using very loose terms here because there's a number of reasons why that might happen. BIBE segmentation gives you the option to cut it into a number of smaller pieces, put each of those inside another bundle and send them individually to the decapsulation point, which will know to assemble them and put them back together. And this 4th bullet applies to this document less than the CCSDS document. I know that I attend CCSDS as well as IETF. So the CCSDS document has taken a number of iterations because there has been a sticking point about whether to strictly prescribe all this behavior as a CLA or as a service, or how does it fit within that ASCII art diagram we were discussing in Sabrina's discussion. Where does BIBE fit? So in the BIBE document as it stands now, I have avoided all of that by saying it's behavior. Its functions. I have described what must happen and haven't tried to fit the square peg into any of the round holes that are available. So that's an intentional sidestepping of where does this fit in the architecture? And it's saying you can put bundles inside other bundles, and here are the responsibility of the person of the actor that puts the bundle inside another bundle and the actor that unpacks a bundle outside of it. And you work out how that fits within your implementation. And that has actually made the whole document easier to write. So hopefully that sticks. I'm not going to go too deep into the use cases. These should be well known. Yeah, you might want to add security over a short subpath within your end-to-end path, so you can put it inside another bundle, hide the content, put PPSec on it, on you go. You might want to tunnel across a different person's administrative domain because you have less trust in them. You might want to put BPv6 or something else. BPv6 is a better example. Inside a BPv7 bundle and tunnel it across. Sorry. It doesn't require a bespoke protocol for that. Segmentation, I've covered that already. And you might also want to do it for traffic flow control. And these are all pretty analogous to everything that IP does. So this is a read across to say, oh, well, IPs, we've learned many things over the last 30 odd years of IP tunneling. Why can't we have these facilities? Well, BIBE gives you all those facilities. So anything you can do with IP tunneling, you should be able to do with BIBE. And that's a really good litmus test when reviewing that document. If you know of a preferred or a popular IP tunneling technology that is not natively supported by BIBE, that is an option to flag up on the list and say, hey, you missed this. From my survey, I think we have covered it. So you can do IPsec ESP mode stuff, you can do IPsec tunnel mode stuff, you can do standard sort of IP over IP, GRE kind of tunneling. We've kind of got it all. We've got the DCAP multiple endpoints concept, so you can have the equivalent of GRE keying, so you can have multiple flows going to different places, so you can do all that kind of stuff. And it's kind of heading in the direction of segment routing, but we will not say any more about that today. And the key point from the IP tunneling analogy is also we can read across all the security considerations. So we can look at all the operational experience and everything everyone learnt with IP tunneling and say, okay, how many of these also apply to BIBE? So the security consideration section of the BIBE document as stands at the moment, I think is in pretty good shape because I've been able to lift it from elsewhere and correct it and remove things which no longer apply because we're using BP. But otherwise, it's all the stuff we learned doing IP tunneling. But again, have a good review. And those classic examples being recursive encapsulation loops. And there's a fantastic RFC 6169, which just catalogs all of these things. And I've referred through to it rather than cutting and pasting. So the segmentation mechanics, it follows exactly the same pattern as you see anywhere else where you take a big thing, cut it into chunks and try and reassemble it. It looks a lot like TCP/CL v4 segmentation for those of you who are familiar with it. It also looks a lot like BTPU because guess what? We all followed the same pattern. Basically, take a big thing, break it apart, mark the transfer ID. So this is part, these, let's say I have a big bundle I split into 6 blocks. You say all 6 of these blocks are part of the same transfer. For each of those sub-chunks, you record the total length of the reassembled thing and the offset within that total. You have 2 choices when you're chunking stuff up. You can either do part 1 and individual length, or you can do total length and segment offset. It's horses for courses, as the English say. It depends entirely on your environment. It depends on how many bits you care about on the wire. In this case, the authors chose to go with total length and segment offset because it actually makes the reassembly a little bit easier, but it's conceivably 2 or 3 octets more expensive on the wire. I leave it to the working group to discuss the pros and cons on that. I see no problem personally on this one. Because the wire format will support, there is an entire bundle inside this bundle and there is a segment inside this bundle. The payload format has, thanks to CBOR, a single CBOR array. If there's 1 item in the array, it's the whole bundle. If there's 4 items in the array, then it's a bit of a bundle, and those 4 items describe what those bits are. The transfer ID, unlike things like BTPU, which has transfer ID windows, which manage how many individual transfers are in flight, or TCP/CL, where those transfers are acknowledged as part of a completion, because TCP obviously gives you reliability. The transfer ID is just a unique number, and the windowing machinery is excluded because we can use bundle lifetimes. You know the lifetime of the bundle you're encapsulating, so set the lifetime of the outermost bundle to be the same, and equally if you're doing segmentation, that controls how long that transfer should complete, how many are in flight and whatever. We can remove that whole windowing mechanism, which actually simplifies. It's great. Reassembly is optional. You can throw it away. If you get stuff you don't understand, you go, yeah, I don't do that. You can just bin it. Because BIBE is fundamentally unreliable, as bundle protocol is fundamentally unreliable unless you go away and apply custody transfer or know that your underlying convergence layers are all reliable. And this is where Sabrina and Ed are working on that reliability piece. We can copy exactly the same semantics to say, if you receive something you don't understand, just like any other bundle, you just bin it. So that means if you have a particular deployment and you don't care about segmentation, you don't even need to implement it. It's fine. Non-features, I kind of covered this quite a lot. There is no acknowledgement. There is no custody transfer. We fail silently, just like if you don't like the bundle, you bin it. That's fine. There's no extra diagnostics machinery. There's no new exciting status codes. All the existing status reports work. We can point to various places within the mechanics of BIBE and say, you know, this is where a status report gets emitted optionally. It doesn't need new exciting status reports. And the decapsulating note is a policy enforcement point, and it fits within the standard 9171 and 9172 BPSec enforcement model. There's no new mechanics required, which is, I think, a really good sign. And it's running almost in many places. A lot of people, because the original drafts came out in like 2018, various implementations have been fiddling with this repeatedly over time. And as a rough survey of who does something BIBE-ish, ION has the full BIBE-CT implementation because Scott kind of oversees ION and was writing the document, so unsurprising there. Micro D3TN from D3TN does it, but it does encapsulation only. It doesn't do the custody part. DTN-ME, the CCSDS, does the segmentation prototype stuff, but again, only does the encapsulation. Again, didn't do the custody transfer. And I think it's really telling that of those running implementations, 2 out of 3 of them went, yeah, I don't care about the custody bit. Let's just do the tunneling bit, which I think is a really strong marker that that's actually where the consensus of the community is going. We just need that tunneling and that segmentation ability. We don't need those acts. So I think we're heading in the right direction.
Yep. We are a little past 11.
Oh, damn it. Okay.
So what I want to say is just because I know we may lose the meet echo. We do have our second session on Thursday.
We can
and
discuss this then.
we can pick it up then. I know that Brian, you were in the queue. Do you want to make a last comment and read us out? But otherwise, we have about a minute left.
Sure. Yeah. Thank you. One little comment, and it's great that the technical detail is here to be able to discuss this level of detail that I'm going to mention. But on the previous slide about the transfer ID scope, it might be good to narrow this to only observable behavior and say it's encapsulating endpoint to decapsulating endpoint, not encapsulating node, only because it forces the receiver to try to guess what is the node versus what is the endpoint that I see in the message.
Okay, very rapid answer. First off, the word node should probably be in quotes there because this is part of the trying not to say it's a particular part of the architecture that does it. Something in the node has decided that it's going to do BIBE. That's all I mean by encapsulating node. Check the terminology in the doc.
And
encapsulating function.
And let's please have that discussion on the mailing list. Thank you all for being here, and hopefully we will see you all on Thursday.
Got one slide left.
But we'll switch in.
Yeah.
Oh, even with 50 minutes, we went through. It's a good discussion. There's a lot going on.
We did the right thing. We left 25 minutes at the end so we can actually talk about it.
Yeah, which was nice.
It's 2 sessions.
I think that's working quite well. Oh, excellent job. And then it's TVR.